This talk is specifically about my adventures using Godot in VR to simulate big rotating space stations. This is a very obscure niche of video game development, but let's see what we can do with it. Most video games kind of fake the physics of rotational things, so thought I like to explore that sort of realm. So here's a quick video of the kind of stuff I've been working on, just different VR things. VR in Godot Engine is really new, so everything is extremely experimental. I've always wanted to make simulations that give players an idea of what it's like to actually be there, not just like see it on a flat screen, but if you're there, what happens when you're there. So let's talk about space stations in general. In the world of hard sci-fi, you kind of want to stick to, or you sort of stick most of the time to basically known science. And when it comes to gravity, your options are pretty limited because there's basically no gravity, because there's microgravity. You're technically like orbiting the sun or something, but you can't really feel it when you're floating in space. Just like if you want gravity, an easy way is to spin something around and sit on the inside of the surface of the thing that's spinning around. Just like you have a bucket of water and you spin around really fast, the water stays inside. Let's see. And through the years, through NASA and through other things, there's been like practical designs for making space stations from known technology. So Wikipedia has a big page and other space habitats. This one's probably the most impractical one. It's like gigantic thing. Each of those barrels spins in opposite directions, so things kind of, it equals out the twisting motion theoretically. You can support millions of people inside these things. This is an O'Neill cylinder, it's called, after Gerard O'Neill, who in the 70s was trying to get NASA to build these giant space stations in space, and some senators didn't like it and kind of kicked him out eventually, so I hear. So part of my interest in the space station stuff, I wanted to see what things were like when you throw things around. Like you see the movie 2001, there's the station where it's the guy's running around inside for exercise. And it's a very small radius. So I built something in 2 dimensions, this was a couple of years ago, to kind of get a glimpse of what's actually happening. So one frame is what it looks like when you're inside. The other side is what it looks like if you're outside watching this thing spin around. If you throw things in one direction, the balls behave sort of like it is in just naturally, things fall to the ground. Things start to get weird as you rotate around and throw it in the direction of the spin. So like if you throw straight up, things don't actually go straight up and straight down. They sort of bend off to the side. And the more over you go, the weirder things get. So on the left, you can sort of see where the balls are going. Since there's no other gravity, when you throw something, you release the ball is actually traveling in a straight line. But since you're sort of traveling along with it in a way, you don't necessarily see where it's going. And if you're fancy and you get the speed of your throw just right, you can make some pretty wacky things. Like imagine having silly string and squirting it around. That'd be fun. Or it would get you banned from the space station, depending on the administrator. Okay, so that was a 2D version. I've always wanted to do something in higher dimensions, like something that you can just walk around inside. This was kind of a first prototype. You see these other controls on the bottom. Those weren't functional yet, but this is just a kind of a duplication of the 2D scene where you throw stuff around. I implemented a teleport, which is kind of tricky. I'll get into that in a second. So just watching it on a flat screen, you can't necessarily see, like you don't get a full sense of what it is to stand there and throw something. Unfortunately, VR is like it's like the perfect simulation medium because you have this thing on your face and completely controls what you see. You have the controllers that track pretty well, assuming your computer is beefy enough, I guess. So it's very easy to like set up something like this. It's a great place to simulate. aside from actually building a spinning station and standing in it, VR is the next best thing with only half the nausea of reality. Some people get sick with VR naturally, but if it's spinning in space too. There are some studies that say you might get sick, but if you spin slow enough and you have a big enough station, you get less sick. Okay, so that's what we're talking about. Now I'll kind of dig into how to use Godot to make these things. So about a year ago, this guy named Bastian Olich made a plugin for Godot to use Valve's OpenVR to have VR operational within Godot. Other game engines, the proprietary ones like Unreal and Unity, they've had VR going for like all the time the major headsets have been out, but Godot has been a little bit lagging, and now it's slowly catching up. There's still some glitches, but thanks to Bastian, there's now that capability. So he's also made some demo scenes so you can dig into his scenes and figure out how to do pointers and different controls and getting button feedback. Like with everything in Godot, it's a kind of a new engine, and it's gaining in popularity. And every couple of months, there's some new feature that's like really cool, and like more people get on board. They just got an epic mega grant from Unreal to actually pay people more to work on it, which is great. Programmers need to eat too. You can also do AR as well as VR in Godot with the same kind of framework. So it uses a lot of similar technology, like just tracking cameras and whatnot. The Godot main site also has a VR tutorial. I don't think Bastian wrote that, but it has other things like wands, similar technology, or it's like implementation, but done in a slightly different way. So you can see different approaches for how to get stuff done in VR with Godot. So about VR in Linux specifically, I prefer to use Linux because I've just been using it for so long. I have all my tools set up just like I like. VR is a little bit limited. The things that you can use relatively seamlessly with Linux, you have to be running Steam VR, which is proprietary. So if you're okay with that, then you can run the Vive, works pretty well. I have a Vive. I don't have an index. I'd love to have an index, but I've heard that the Valve index works mostly in Linux. There's like a pass-through camera on the front of those, so you can sort of see the world outside you. Like if you approach a wall, it could fade into what the cameras are seeing. That doesn't quite work in Linux from what I hear. Valve has been pretty friendly, so I would expect that to be fixed over time. Vive works pretty well. Facebook's Oculus, their Oculus Quest is something that doesn't have wires hanging off. That's a great feature. However, Oculus software doesn't work natively in Linux. I found a couple of people talking about programming for Oculus on a Linux platform, because I guess Oculus is running some form of Android, I believe. So as long as you can compile something and kind of sideload it on there, it's a very circuitous process. I wouldn't call it a natural way to work. Vive works pretty much out of the box with Bastian's plugin. So with my Vive and my revolving goal, I ran into a number of issues stemming from trying to do things in a rotating reference frame. As kind of just a basic list of things that are issues. When you have a gigantic space station, you want balls to be able to stop on the edges. I can hear the balls when they hit the edge, they just kind of go through and they keep going. I didn't have any form of collider implemented then. The bigger things that you have, the more checks have to be done. If you throw something around as a collider, the physics system has to check whether one collider hits this other gigantic collider that has thousands of pieces, and that can be very inefficient. There's a couple of different ways to work around that, like having a special check for kind of co-opting the physics system, putting in an extra check if you're near the cylindrical boundary, just reverse the velocity. That's kind of what I've gone with because it's the easiest to implement. Other ways that I'm kind of toying with is I have a kind of a moving collider, so you only have to make objects for a small portion and then just kind of keep track where objects are. So the physics engine only has to actually check a very small area. It's much less resource intensive, and VR is all about optimization. You want to run about 90 frames per second. If you get less than that, people tend to get sick. It's just something to watch out for. let's see, objects floating around need to detect collisions with a huge shell. Another big problem is that most of the tools and the examples and demo projects assume that gravity is like straight down. And in Godot, y is up. So negative y tends to be gravity. And there are multiple parts where you have to either turn off gravity entirely and do something else, or like the teleporting is, for instance, the object that sticks straight up. There are many parts in the example code where if you move along the cylinder, it just your object kind of starts going up. It wouldn't orient properly. So I had to learn all about translation and matrices in the Godot system, which is mostly good. I've used Unity Game Engine a lot, and the transform language in the code is a little bit more straightforward, I think. In Godot, sometimes there's, like they use the word translation for moving in a straight line, but sometimes it refers to in your object space, and sometimes it refers to the parent space of an object. And there's another completely different transform for a world space of an object. And there's a little crossover that's a little confusing. Once I figured that out, then I can make the teleporter move and like orient itself properly. The teleport line that casts the parabola out, so it's kind of a dotted line. It took me a while to realize that in there is also a hard-coded gravity vector going straight down, y negative. It took me forever to figure out that it was inside of a shader. So the parabola that's being rendered is using what's called a vertex shader. It's basically just a rectangle, and then at the point of rendering, it's bent into a parabola. So each frame I have to pass in what is the actual down direction. Then I could get the parabola pointing in the right direction to teleport around. Also with rotating reference frames and the physics engine, picking up and dropping things can sometimes be a problem. Because when you pick something up, it's no longer a free-floating object, so you have to configure stuff around it and sort of remove its velocity. And then as soon as you pick something up, you're in this big thing that's moving, so suddenly you're moving kind of in a non-linear direction, and keeping that same velocity, like when you release it, it's a little glitchy. It's kind of difficult to synchronize picking up and dropping off of velocities. One thing that I found in Godot that I haven't found a workaround for, like 3 times out of 4, when I start the Godot playback, the frames per second drops to like 10 or 11 for unknown reasons. It seems completely random when it does or not. So I've got to stop it and then restart it. Like just stop the playback and restart the playback. And then suddenly it bumps up to 90 frames per second. So I wouldn't say VR in Godot is like perfect or like ready for production, but it's enough to be getting on with. And like I said, Godot development is advancing so quickly that I have high hopes that stuff like this will be ironed out fairly quick. More people are getting into VR with Godot. I found a few people on Twitter especially that are like posting stuff, but it's not a lot of people using it yet. Okay, so that's the basics of just like getting VR to start. So this is kind of a first test scene. Just walking around stuff and throwing balls around is one thing, but once you're in VR, you don't want to have to like lift up and mess with your keyboard to like change different settings. So I did controls. This was the first attempt at controls. This is a very naive implementation of buttons. It doesn't rely on the physics engine at all. It's just a controller that has kind of a ball around it. When it approaches another thing, it activates an animation. So you can turn this engine on and off. See, one thing about assets, like in this engine, I just found something on blend swap for, you'd think it was a CC BY Blender file. So I took that. It was just a jet engine for an airplane, so I kind of cut it in half and reversed it, so now it's perfect for a space station instead. Although it's using its own fuel. It's not like an actual jet engine, it just looks cool. Other places where you can get free assets, something that's easy to use, are Smithsonian, for instance. They just opened up like thousands of images and a whole bunch of 3D models that you can just download and repurpose. Video game production requires so many things to to make it work, that it's doing it all by yourself is very difficult. It's hard to pay people with exposure dollars and convince people to work for free. So it's very expedient to use objects that you can find. If you're a starving artist like me, it's helpful to have sources like this. Sketchfab also fairly recently has a whole section where it's a bunch of CC0 models, so you can just download and use. Sometimes on here you can get some low poly stuff that works pretty well. One problem with free stuff is that often it's not quite what you need. Like, it'll get pretty close, but like maybe it'll just have a texture, but it won't have a bump map. Or maybe you want some extra shadows from ambient occlusion, and it's not provided. So, but you can bring it into Blender, kind of try to mess around with it. There's some other material tools that you can take an original image and then generate bump maps from it. I believe GIMP can do that, like make normal maps. Pretty sure I've used it there. I think Krita can do it also. Take an image and then generate other maps that you can use. And one further note about modeling. When you go into games, especially, you need things to be easy to access and walk around in. So always name things meaningfully. Like in Blender, you make a cube and you duplicate it, it'll be like cube point oh whatever. These are not meaningful names. Never do that. You'll hate yourself in the end. And similarly, parent things properly. If you have a bunch of things that are supposed to go together, it's convenient to just like group them together. Otherwise, you'll have a list of like 100 things, and if you set this project aside, come back a month later, you're not going to know what you're doing. Or if you bring someone else onto the project, they're going to hate you. So it's name things properly, do parenting properly. Also, when you're modeling in Blender, for instance, you can set the world scale. That's really important when you go into pull things into Godot and then go into VR. Because you might make a ball that you think is like this big, and then you get into the VR, and it's actually this big, like really huge. You can avoid those problems if you just like make the object in the proper scale at first. Sometimes it also confuses the physics engine. If you have a ball or something that's scaled weirdly, the physics engine will not interpret things correctly. You get some weird movements, which can be fun, but it's also difficult to debug. Okay, so those are kind of the basic pieces, teleporting objects. So I put them all together into this next experiment, which is kind of a dumbbell station. One form, it's like the simplest way to manufacture a station that spins around, something with a truss or a big rope between it, and then have two things on either side, just like you're spinning a bucket, or maybe two buckets around of water. And I put an elevator just to make you especially sick as you move around. I don't really tend to get sick myself in VR, but when you're standing there and you see the entire field of view just as stars and it suddenly starts to rotate, that is really disorienting. I was not expecting how kind of strange that was. I almost fell over a few times, but it's kind of interesting. I think I've mostly gotten used to it. And I needed a backlight. The previous version of this video was really dark, so I decided to put Jupiter in as a backlight. And here's another iteration of the dumbbell concept, where instead of just one station, you have 4 stations. And you can also do overlays like this in Godot. It's like a 2-dimensional scene that you're kind of tacking onto a 3-dimensional scene. So this is kind of, if you imagine a cube, and each 4 faces of a cube, excluding the top and the bottom, if each of those has one of these dumbbell stations, and then have them rotate around, they rotate in such a way that they're like gears meshing together. So it looks like they're going to smash apart, but they never quite do. I would totally live there. I think that would be fun. Okay, so the engine had kind of just basic push controls. So this was the next iteration of making controls in Godot, a little more complicated than just using a pointer to call a function on an object. In Godot, you have objects, and each object can have one script attached to them to do whatever you want in it, or you can have subnodes that have other scripts on them to do other stuff. So each of these controls is kind of a separate conglomeration of nodes with different functions to call. There's a few different classes of things going on here. So like the thing with the ribs on it, that's just something that goes up and down. So the controller has a kind of a contact hover ball around it, and whenever it comes in contact with the control, the track control, it detects that there's a collision going on, records the position. Then when you move the controller up, it just takes that distance you're moving the controller and translates it into appropriate distant movements for the controller. It's not a full actual physics system. Physics gets really complicated in VR because you can't really control actual physics with your hands, because you can go wherever you want except for physical stuff, but in VR there might be something right in front of you that you're not supposed to be able to go. Your hand can go right through it. If you have an actual physics object tied to your hand, it's going to be kind of unpleasant. Like you might go into it and then suddenly the physics engine will say, oh, there's a conflict, I don't know what to do, let's send this object 10,000 units away. So, but this system is much simpler, where it's just an area, there's no actual physics to it, it's easier to control. There's been some things that do physics in VR pretty well, like Boneworks, for instance. It's a game that's does pretty well. You have to have continuous movement, so some people get more sick with continuous movement in VR rather than teleporting. But the technology keeps getting better, the frame rates keep getting better. Okay, so that's controls. The next step is being able to grab stuff rather than just throwing balls out of my hand. So this was experimenting with the physics engine itself, things I can pick up and release. This environment is not spinning, so things kind of work pretty well. That's sort of what the physics system is designed for. You can pick up and drop stuff pretty easily. When the ball bounces, there's a trigger on it, so when it detects a bounce on the ground, it changes the lights, or the hand has a trigger on it, so when you cross the line, then press the button, it changes. Uses the same function to control just a color on a material. It's pretty straightforward to do. There's just a few lines of code in Godot to access materials and change stuff. It's very easy and accessible. Another thing about collisions, Godot, like other game engines, can do layers and masks. So you can assign one object to be on a particular abstract layer, and you can tell it, okay, I'm only going to collide with this class of object. And you can set up really complex interactions. Like you can set your controls to be on one layer, and then all of your objects on another layer. And so maybe you can only pick up some types of objects. Maybe you have to be holding a certain tool to pick up some tool, some other basketball or whatnot. You can get pretty complex arrangements of stuff. So for the basic physics stuff, I'd say Godot is on par with the proprietary stuff. Then this was kind of bringing it all together into a single round station, playing basketball. That's kind of fun. So finally, I was able to simulate just like the 2D version. Pick something up, throw it into space, fail to make a basket, and repeat. And you might notice that it bounces really hard off of that board. That's kind of the glitchiness of rotating the entire station in Godot. One way around that I haven't quite had time to implement yet is, instead of rotating the whole station, have the station stationary in the Godot world space, but rotate the background. Then each time, every frame you can change the velocity of objects. So since objects are just rotating, that's mainly what's changing, not the actual magnitude of its velocity. So each frame, just change the direction your velocity is going. Then you can have much fewer glitches and like picking up and dropping objects. I haven't had time to implement that. It makes it harder because you have to render the background somewhere else and then kind of attach it around. Yeah, it's complicated by the fact that the giant round thing is not an actual physics object. It's just something I'm trying to intercept the physics engine and do other stuff. So that basketball stadium is still pretty small. Like a lot of the NASA proposals in the 70s, for instance, the Bernal sphere here. This is a painting by Rick Giddis, I think his name is. It's this big, massive space station. So this is considerably larger than my little tiny basketball stadium. So there's numerous problems in trying to implement something this huge Uh, I haven't implemented the little like garden party down there yet, so future versions perhaps. So how do we actually up the scale of things now? Again, with video games, optimization is very important. With VR, doubly so. Everything has to be rendered twice, once for each eye. And it's got both of those eyes have to be like 90 frames a second. Technology is advancing so rapidly, so things will get better and hopefully cheaper. When rendering happens, there's a bunch of objects. Each object has different materials. And to render, say you have 1,000 trees, and you want to render all of those inside of this big ball. One way to do it is just make 1,000 trees and then render them all individually. And it requires a bunch of draw calls back and forth to your rendering card, your video card. But this is very inefficient if you have instead 1,000 instances of an object, and then maybe make a custom shader to have different foliage or like different bending of things. You can get away with only a single draw call. Godot has something specifically set up to handle this called a mesh instance or a multi-mesh instance. So you can have like thousands and thousands. I did one test that had about 10,000 little test boxes, and it barely slowed down the 90 frame per second. So I was very happy with that. So I think there's a way forward to make something that's fully walkable around, that has lots of different variations of stuff. And this was kind of my first, whoops, what is that? There's also menus in space, I guess. Okay, so the first example of trying to scale things up, and this one has 3 different mesh instance objects, and each of those instances has like about 100 things going around. The stairs on one side are one object, the stairs on the other side are another object, and the pathways are a third object. And it works pretty well. I still get close to 90 frames a second. One thing is trying to move the colliders along with the scene. I have in here, you can walk up the steps, but there's only colliders on a tiny portion of the whole thing. So if you move across a sector, then the colliders just like move to the side with you, so that you only have to check, the physics engine only has to check particular small areas at a time. So far, it's been pretty efficient. I have a lot of plans for this one. Those big spikes that go up the ribs, those will eventually be trees, so you can take an elevator up and like walk around tree branches. That's my goal, not quite there yet. So here's we're trying to bring in my throwable objects into this new station and trying different ball types and interaction levels and custom shaders and other stuff. Each of these mesh objects within the bigger multi-mesh thing, you can have as many materials as you want, and each material can have different shaders on it that do like deforming or different colors or other custom effects. Or you can have star children just kind of hanging out. And the star child, by the way, it's built from 2 CC0 assets. I think I got this off of Sketchfab. One was just a baby head, and another was a hand. So that by themselves they were great, but I wanted to use them together. So I could use Blender to kind of blend them together, do some sculpting to build out an arm. Having assets that you can download somewhere is a great help for speeding things along. Speaking of models, if you build things in Blender, sometimes exporting and then importing into Godot can be sort of problematic. Some formats work better than others. Prior to the new 2.8 version of Blender, there was something called a better Collada exporter that was pretty faithful, keeping the Blender setup and then importing into Godot. But that only worked in 2.79. Then when the Blender 2.8 came out, which has much better features pretty much across the board, that part didn't work anymore. Then for a while, you could export as GLTF or GLB, and those imported into Godot sort of okay, but often little glitches. Lately, though, in the Godot 3.2, the most recent version, I've had almost no problems importing GLBs. That includes animations and materials. And sometimes if you build up a whole node system for materials, that's not going to translate so easily. But if you have just simple PBR materials with like bump maps and other stuff, those import pretty easily. And the previous one, I felt kind of bad about throwing the little baby into the air, so I made a part 2. So I made a little kind of like space baby bouncer to stick it in. But you never quite know what's lurking in space, so. And since that guy stole my child, just hop on the monolith and take off after it. And the dinosaur, again, so I think that was on Sketchfab also. That was one of the models that it had a great texture to it, but there was no normal map, so it just looks kind of flat and shiny, and it's not quite perfect. There was no rigging to it, so all that extra stuff I had to do myself. The dinosaur did not come with the rotor blades, so I had to add those on specially. Yeah, so this is in Blender. Adding in rigging, trying to do some animations, and then import those into Godot. In Blender, you can set up IK chains, where you just have a string of things, but you only have to pull one thing, and then it pulls everything else. It's still all on a flat screen, though. Sometimes that can be, especially after using VR a bit. I've done some sculpting in VR, and it's amazing how just more intuitive and immediate it is to do those things. But especially in Linux, there are no tools that allow you to do that in VR yet. So I've added that to my to-do list. Kudos. They're like clicking around in Blender and adding all of these things. It takes forever to like make something that's like reasonably good. But with VR, if you can just like see the thing in front of you, just put things in 3 dimensions, it's much more intuitive. I think there's a lot of potential there. Here's the animation attempt at grabbing stuff. Godot has an animation tree. So if you have multiple animations, you can set up this kind of 2-dimensional grid of how you want things to perform. So it's an easy way to blend different animations. So you might have one animation that's like grabbing, another one that's like rotating the blades, and you can kind of put those together. And you might notice one of those rudders is like underneath them like a unicycle. That was not intended. That's one of the few glitches I found importing stuff via GLB file format into Godot. Just sometimes things kind of get squished around and it's not quite seamless, but it's certainly enough to kind of test things out. If things pop up like that, I've been able to just delete those extraneous objects, and then there's usually been enough to work around the peculiarities of Godot importing. Many things about Godot. I have this long growing list of quirks about Godot that kind of annoy me. Like, for instance, this is all just a single screen, and when you start to do game development, you might want to have one window for like a model, one window for your scene, another window for script editing. Maybe you have multiple monitors, but there is no multiple monitor support natively in Godot. But that's changed as of like last week. They finally implemented multiple monitor support, essentially, where you can have tear off windows and spread out your workspace. It's like every month, sometimes every week, they add new features. It's pretty dramatic to watch the speed of development for such a small team. And one thing about making videos of VR stuff, these are the tools I usually use. They're all open source, cross-platform stuff. I've basically had no problems recording video and then putting stuff together either with sound. I use Kdenlive for the actual video editing. Special concerns about making videos in VR. Sometimes I'll record something and then I'll go to watch it, and I was accidentally standing like 30 degrees off kilter and I didn't realize it, or something that I knew was sort of in front of me. I just intuitively knew it was in front of me, but then I just like watched the stars or something, and then I go watch the video and it's just me watching the stars instead of the thing I was actually trying to make a video of. So it's just other weird concerns to be aware of when making VR marketing materials. Uh, and Godot has a lot of, or it has some add-ons, just like Blender has a million add-ons. Sometimes you get the main piece of software, but to do the really cool stuff, you've got to happen to know or stumble across this add-on that does everything you want. Like in the earlier video, there's a big truss that goes between the dumbbell station. That's part of an ArchiPack plugin for Blender. There's just a thing, I want a truss, so you click the button and it gives you a truss, then you can export it. It's very seamless and looks pretty good. So this guy, Calino, I think he's a Godot developer. He has this gigantic list of resources that can go along with Godot and help speed up development. I put together my own list of resources, like the Smithsonian link and some other stuff that I found useful in developing all this stuff. And my next stop is to go to Mars, I guess. No one really knows what the effect of limited gravity on human bodies are. We have a lot of data on 1G gravity and a little bit of data on 0G and nothing in between. So even if we go to Mars, like certain billionaires want us to do, I guess, we don't know if we're all just going to like grow really weird and die young or something. So if you want to have 1G, you can do a rotational environment, but it's basically a conical shape. So you have to stand on the inside of a cone rather than a cylinder and spin that around enough. And then you can get back up to 1G, hopefully make your back grow straight or something. So that's my next simulation experiment. And I guess that's my talk. That's what I've been doing. If you have any questions, I would love to answer them.
Thank you, Tom. Does anyone have any questions? I'm like mildly nauseous. I have bad motion sickness.
For an actual implementation in some of these, would some of those problems be lessened if you were to use a local gravity system, but show the further off the backgrounds and those things as rotating elements to give the impression of the overall rotation? But since in those cylinders and in those gravity, in those rotating reference frames, the local results for the most part are similar to whatever G you decide to go with for the station. So would it have been easier, or would it be easier to go forward for simulating something like that, to say I've got local gravity where I am, it's going to act like normal gravity for the most part for most things, and then let all the other views look rotating from my reference frame, even though they're really not. Is that like a viable path forward if you wanted to?
In some situations you can, like the bigger radius you get, the more it resembles actual gravity. So past a certain point, things are not going to behave weird unless you move up toward the center. And the problem is, if you want to be able to walk around anywhere in it, if you want to have elevators that go to the center, then things exhibit the peculiarities. Then having a local gravity that just like forces things to go straight down, it'll end up making them just go straight down. It won't have the strangeness. It's very direction dependent. So even if you're throwing something at the same speed one way, it's totally different than if you throw it the other way. It's very difficult to simulate that with only a single gravity override.
So in addition to stuff, to modeling stuff moving through the air, do you also have a plan to make it so so that when you're on the ground, like that depending on how wide the radius is, it'll actually like instead act kind of like a slope and have stuff like rolling back due to the a bit is when that happened when that happened in a real Unreal cylinder?
Yeah, to an extent, yes. That's one of my biggest problems right now, actually. If I throw a ball around and it gets close to the ground, quote ground, if the velocity is slow enough where you would expect the ball to just kind of stop, the collision detection is, there's just enough rounding errors that instead of just stopping, the ball just like behaves really weird and shoots off. So in an actual environment, if it's just a flat surface, a cylinder, you can still have things like fall down and stop and stick to the ground. There's enough friction to kind of keep it staying there. So you wouldn't necessarily see a lot of rolling. On the conical environment, like if you were to build something on Mars, that's definitely more of a problem. There's only like a sweet spot where something would kind of stay on the ground. Otherwise, it'll kind of roll off to the side, either up or down. In an actual environment, you probably want to have enough furniture and like little potted plants around to prevent things from rolling around in strange ways. Just in basic cylinders, I don't think that would be so much of a problem.
So, but in certain environments, but in certain environments, if you wanted to have a cylinder that was narrow enough, attempting to make it act as if you were standing on a slight slope be a way to implement that, or something? Like basically, if something is meant to be at rest on the ground, like telling it, okay, instead of pretending you're on a flat surface, pretend you're on an unlevel surface. Would that be a way to implement it?
To use the pure physics engine, there's not, even if you tell it to move a little bit just with forces, it'll still kind of move around a little bit. What I'm going for now is instead of trying to use the physics engine to simulate that either with slightly sloped walls to get it to stay, I'm just trying to detect the velocity. If it's low enough and near enough a floor, then just like flip a flag so that it's no longer a physics object, it just sits there. And then when something else comes in contact with it, then turn it back on to being a physics object, and then it'll bounce around. That seems to work pretty well.
All right.
Yeah, it's mostly rounding errors that cause these glitches. So if something's just purely a pure cylinder moving around, it's not going to roll too much.
It's just a thought that came to mind.
Mm-hmm. Thanks.
Any other questions? No? Thank you, Tom. Very
All right.
interesting.
Thank you all.